For the next 3 slides, I recommend that you write down the information, vocabulary, and stuff. You do not need to write it word for word, but you do need to know that what a function is. You need to know the function notation, what an independent variable, what domain is. We're going to be working with domain a lot this year, and range. Make sure you write some of the information down, probably better in your own words. These are all the parent functions that you will be working and have worked with. For example, the constant, the linear function, and the absolute value. I know that we teach it in Math 1. In Math 2, we do absolute value and quadratics. I'm going to say that in Math 3, you do a lot of the cubic and cube root and reciprocal and logarithm. I know in Math 1, we also do exponential growth and so forth. For this function, it's very important that you understand even function and odd function. If you notice, they say that an even function reflects across the y-axis. So this little piece right here, it's reflected over. So this is why it's called an even function. And an odd function, it reflects over the x-axis and the y-axis. There, you can see where it reflects across. So this is a reflection on this side, and it's also a reflection for here if you flip it over. So it's a double reflection. This is the function that we use like for a parent function when we're doing vertex form, or when we're doing absolute values. This is your h and k, which is your vertex. It's for the absolute values. And this is basically the h is your movement left and right. Your k is your movement up and down. For origin transformation, the shape does not change. It stays the same shape, same size. The only thing that happens is your shifted horizontal shift, a vertical shift, or reflection. Your reflection is basically your A, if it's negative. Your vertical shift is your K, and your horizontal shift is your H. For non-rigorous transformation, it's the same shape, but it's dilated, so it gets either smaller or bigger. So we're going to be graphing linear equations, and for linear equations, basically all you need to know is your slope and your y-intercept. Your slope is basically the number that's in front of your x variable. That's your rise over your 1. So in this case, our slope is going to be 1 over 1. So that means up 1 over 1 since we have a positive slope. Our y-intercept is our b, and that b is basically going to be 0. And if you put it as a point, it's going to be 0, 0. That means you always start by graphing your y-intercept, which is 0, 0 at your b. From that point, you're going to go up 1 over 1, up 1 over 1. And you keep going. I need to make a lot of points just because I can make a straight line. So that kind of helps me guide to make a straight line. And you kind of want to make straight lines. And this would be your parent function. All functions, all linear functions come from that function. Either if it has a negative steepness or positive steepness. This one has a positive steepness because it starts at the bottom left and rises up to the top right. So that's a positive slope. For our next graph, we have our slope and our y-intercepts. So our y-intercept and our slope. So our slope would be 2 over 1, which would be up 2 over 1. And our y-intercept would be 1. If you put it at a point, it would be 0, 1. So you always graph your y-intercept, so that would be 1 here. And from that point, you rise 2, and you over 1, up 2 over 1, and so forth. Down 2 over 1, down 2 over 1, down 2 over 1, to make your nice straight line. And this would be our second function, so let's just call this A. Our third function would be the green one, which again, the slope for this one has a negative slope. So that means down 2 over 5, and our B is 1. If you put it as a point, it would be 0, 1 again. So we have, it starts here, and we go down to 1, 2, 1, and 5 over. And that would be our point. If you want to be very exact, you could go from back to your y-intercept and go up 2 over to the left 5. And you make your straight line as best as you can. And now we're going to actually describe how the graph is related. If you notice, when we're going to be comparing the blue line and the red line, if you notice that the red line is way steeper than the blue line, so steeper, and it also got, from the y-intercept, it got translated or shifted up 1 unit. So when we're describing it, we could say the function is steeper and shifted 1 unit up from the parent function. If we're looking at B, so now we're comparing our blue, which is our parent function, with our green. If you notice on that one has a negative steepness, and it's also got shifted 1 unit up. So for that one, the function has a negative steepness and got shifted 1 unit up. This problem we did in class, but I'm going to go over it one more time. This is our absolute value function. Our absolute value function, we have an h and a k, and we have an a. Our a is basically our slope. In this case, if there's nothing here, it's 1/1. Our h and k for an absolute value is basically our vertex. The first coordinate is the number inside of it, and since there's no number with the x, that's 0. There's no number being added on the outside of the absolute value, so that's 0. So that means our vertex is 0, 0. Basically, this point right here is our vertex, 0, 0, and we go up 1/1, up 1/1 to the right, and we do the same thing to the left. So up 1 over to the left, up 1 over to the left, up 1 to the left, and this would give us this blue parent function of the absolute value of x. Same thing we're going to be doing for the red function, but for this one, if you notice, now we are adding a number outside of the absolute value. This absolute value function has that 2, which this 2 is a vertical shift up 2 units. Since there's nothing being added to the x, that means there is no horizontal shift. So that means our vertex is 0, 2, because there's no shift inside, and there's a up 2 shift there. So that means our vertex now starts at 2, which is 0, 2. And the same thing, if you notice, this is 1/1. So we go up 1/1, up 1/1 to the right, and then up 1/1 to the left to get our new function. And if you notice, if you compare the red function to the blue function, you notice that the difference is that it was translated 2 units up. Or shifted, whatever you want to use. So that's why we wrote the function was translated 2 units up. For our next one, we graphed the f of x equals absolute value of x minus 3. If you notice, now we have a actual shift inside, and that's a horizontal shift, and we had no vertical shift. When we have a horizontal shift, you always have to use the opposite of this number. So the opposite of -3 is 3, and then our vertical shift is 0. So our vertex ends up being 3, 0. So instead of this point being at 0, 0, it was a horizontal shift to the right 3 and no vertical shift. So that's why we said that the function was shifted 3 units to the right, and that's the only difference between our original function, which is our parent function in blue, and our green function. Now we have a square root function, and for our parent function there, it's basically going to be the same thing. We start at 0, 0, and we go up, and it crosses our 1, 1, and then we just graph it. For our green function, it starts at 0, 0 still because there's nothing here. But now our other intersection point is up higher because now it's stretched, and it goes like this. And for our last function, there's no stretch, it's the same function, but it got translated up 4 units. So we start here, and it goes through 5, and it goes like this. So for A, we could say that the function is a vertical stretch by factor of 2. And for B, we can say the function was shifted 4 units up. And now we have that this is our f of x is equal to the square root of x. And then this would be 2 square roots of x. And lastly, we have the f of x is equal to square root of x plus 4. So this question says identify the parent function, write a function of the graph below using function notation. If you can see, this is basically going to be a square root function that was reflected over the x-axis and shifted up 1 unit. So we have f of x. When something is reflected over the x-axis, we have a negative, and we know it's a square root, and it was shifted up 1 unit, so plus 1. The parent functions for quadratics usually start at the origin, and they go up 1 over 1, just like the rest. If you notice on this one, the only difference is that it got shifted down 1 unit. So for this function, we know that f of x is a quadratic, which is x squared, but it got shifted down 1 unit, so it's minus 1. For this function, it's an absolute value function, so all we really need to do is identify our vertex, which is this point right here. And our vertex is 4, -3. So when we're writing our function, we're going to write f of x is equal to our x minus the opposite of our h, which is -4, and same k, -3. But if you also notice, this function was reflected, so it's going down. So it means this absolute value function is negative. So that is our absolute value function for the equation number 1, or graph number 1. For graph number 2, it's a cubic function. So we know it's a cubic function, but it also got shifted. And we have this point right here where it's where you change the direction. And that point right there is going to be 1, 1. So again, we know it's a cube, so it's a cubic function. If we're going to have the opposite of the first, our h, and the k stays the same. So opposite of 1 is -1, and our k stays the same, so that's plus 1.